Okay, let's get started. All right, so what we're going to do is we're going to kind of lay the format of what's going on in this industry. It's again, like I said, I've been watching this thing for 15, 16 years, and I just cannot believe what's going on. It all started with a big bang, boom, in 1985, I think, 1984, 85. What happened back then? I don't know if you guys remember Lotus 123. You remember Quattro. You remember Excel. Those initial BI tools that kind of spawned this whole generation that we're seeing today. You're also seeing desktop publishing that started exploding in 95. The client server, Oracle released their first client server application in 1985. And since then, I basically call that a big bang. It's been an inflationary, just like the universe, if you guys read about astronomy and stuff, just an inflationary universe that just keeps on going. The thing is, it keeps on accelerating. This industry just keeps on accelerating. It is quite amazing. So how do you keep track of what's going on? There's a lot of stuff going on. So this is what I want to share with you today. So I only have 25 minutes. I may go a little fast. If you want more drill down, just click through. Just grab me somewhere. We'll chat. We've got 19 trends that, in IND that we track right now. There's always adding more and taking some off that don't seem relevant. So what we're going to do is just do a little virtual factor analysis and kind of collapse those 19 trends into 15 that we can say that there's three latent factors there, three latent areas that really that's going crazy right now in the industry. So one is we call high performance computing. I think that's kind of a general term that we've allocated some of the trends towards. And we'll spend more time on that today. I think the big data is of interest. There's a lot going on in that space, and I'll try to educate you a little bit on what's going on with big data. And then we'll talk a little bit about cloud, federated data, master data management, the end of the data warehouse, which is kind of controversial. And I'd like to get any feedback that you may have. Is the central data warehouse, is it dead? And I think it is, but we'll talk more about that. So we'll talk about another big trend, usability and visualization. This is all about the consumption of analytics, right? And I've got some stories we'll talk about dashboards, how they're going to evolve out of being a dashboard. A dashboard is so Nixon. It's so 70s, 80s, all right? You got to move beyond the dashboard metaphor. We'll talk about that. We'll talk about the importance of visualization, the importance of aesthetics. Aesthetics is important nowadays, and how you have to design applications. We'll talk a little bit about that. And then we'll talk about graph analytics. Beautiful space. It fits very nicely into what we're talking about for improved visual interfaces. I'll show you some pictures there, and you'll get that pretty quickly. And then we'll talk about what we're saying the third big meta trend is intelligent systems. Okay. Intelligent systems, what are those things? These things are about man-machine. Man-machine to make your job easier, to extract more value from your data. It's not only real time, it's just about man and machine working together in the analytics industry in a more improved way than we've ever seen. And there's a lot of trends in that space. Something called pervasive analytics, something called real-time and event streams. We'll talk a little bit about that. The things in bold we'll talk about. The things that aren't bold, we just don't have time. Artificial intelligence, AI, it's not what you expected. It's everywhere, but it's not what you expected. We don't have little robots running around, but there's a lot of AI going on, which we can talk about. Don't forget the fourth tier. It's very juicy. So I see a lot of people designing BI systems, analytical systems. They forget about the fourth tier, which is the advanced analytics layer. Your optimization engines, your SAS, your R, your analytics engines, that whole area there, people tend to forget about. And it's juicy. What I mean by that is squeeze the orange. You can really squeeze the orange, squeeze your data assets. Meta-heuristics and the ants, another huge trend. This is about these class of biologically inspired algorithms in the optimization space. So you don't have to be nervous about trying to figure out all these complex optimization problems with all these numerical methods, these mathematical programming methods. There's these beautiful meta-heuristic algorithms, particle swarm, genetic algorithms, simulated annealing, ant colony optimization. All these, there's a whole class of these things. You just go into Wikipedia and click meta-heuristics, you'll just see all these crazy algorithms people are creating. And you can utilize them. They're very easy to use, and it really brings down the marginal cost of using optimization in your applications. Next thing we'll talk about a little bit, operational analytics. You are the exception. Big trend. Exception analytics. Big trend, right? How do you create an exception analytics system, right? Probably everyone has dashboards, and okay, so what is what you're looking at? These can help you. Experiments, we're not going to talk about that, but that's huge. It's the hallmark of a very successful analytics shop. Whenever I go to analytics shop and start asking questions, and I see they've got test and learn implemented, they're doing experiments in the enterprise, that's the best practice. And I know that that shop is on top of their game if they've got experiments and they're implementing experiments. Then we'll say, and the last one is just say no to OLS. What I mean there is just don't run regression all the time. Please just don't run regression all the time. There's so many other techniques that you can utilize for predictive analytics, for insight. If you're interested in that, grab me. I can show you demos and show you the code, and you guys can run much more things than regression and logistic regression. So that's kind of the the meta trends, the micro trends, and how everything fits together. Okay, so let's start with high performance computing. Big data, man. It's around us. It's everywhere. These waves. I mean, you just know it's here. What do you do with it? It's no secret that we're inundated with data. And so, how's the industry responded? The industry responded in two ways: in a commercial way and an open source way. In the commercial way, you've heard of in-memory analytics, right? In-memory analytics. You guys are familiar with in-memory? So what's happening there is it's about agility. It's about the business user wanting control. It's about integration of disparate data sources and not using an intermediate data warehouse. Basically, crunching, integrating with third-party and different data marts and different sources, and integrating it in memory, and then getting a result, rather than having to ask your data warehouse team to build a data model and build data marts to have a have an intermediate repository. And then you've had all these vendors, Vertica. These are all big data vendors. Vertica, and I'll show you in the next slide, they're all gone. There's only a few left. They've all been purchased. So if you bought stock in some of these and the new big data was happening, you would have made a lot of money. So Vertica, Teradata, Astrodata, Greenplum, Netezza, Cloudera, now we're going to open source, and Cassandra, if you've heard of that, and then Hadoop. We'll talk more about Hadoop in a second. It's about the MapReduce algorithm. It's basically caught the whole industry by fire. Everyone's basically in the big data area. Even the commercial vendors are implementing MapReduce or talking about MapReduce. So we'll give you a real example. After this talk, you will understand what MapReduce and Hadoop is about. There's also a whole ecosystem under Hadoop. There's HBase, there's Hive. These are all different types of databases. There's Mahout, which we'll talk about specifically for the analytics discipline, to create MapReduce algorithms, parallelizing your algos for the big data. Okay, so what's happening in the industry? So EMC buys Greenplum, right? That's a massive MPP, massive parallel processing vendor. Basically, what all that means is a distributed cluster. So I take my data, I chunk it up, and put it on a cluster of nodes, right, and crunch it. So EMC buys Greenplum. So they needed that big data. IBM buys Netezza in November 2010. HP buys Vertica, right? You guys, this is crazy what's going on. So Vertica, another columnar-based storage vendor, big data vendor. HP buys them, takes them out. Teradata buys Aster. That was if you played Jeopardy, you would have known that. And that's a MapReduce vendor and an MPP vendor as well. And then SAS comes into the play, right? Just recently, April, they make an announcement, HPA, high performance analytics. And they're saying, we're not going to work with Netezza anymore. Go away. We're not going to work with IBM. Go away. You're a competitor. We're not going to work with Aster. Go away. We're going to only work with EMC and Teradata. All right? So in database processing, high performance analytics, they're calling it for EMC and Teradata. So SAS is coming into the fray. And then you have open source vendors. So Apache Hadoop and MapReduce. And this is used by a lot of e-commerce online vendors. They basically blaze a trail, and then a lot of other industries are picking that up if you need big data solutions. And we'll talk a lot more about these in a minute. All right, so that's industry activity. And just last week, IBM launches Hadoop-based analytics software. They're putting $100 million behind it. So this was just last week's news. So again, you can see how exciting this industry is with respect to big data right now. A lot of things going on. Okay, so let's go a little education. Big data. A few ways exist to process large data. So earlier on in the day, back in the Cray days, IBM Big Iron, Sun is a proponent of this method a lot. SMP, symmetric multi-processing. Basically, it's just one big machine, right? You've got a lot of processors. It doesn't scale really well with a lot of data because you've got I/O conflicts. Right? The I/O starts overwhelming the system, right? So it doesn't scale the huge data because of that. You've got simpler coding, though. It's a huge advantage. There's a big dark secret with parallel processing. You've got to code these algorithms in parallel, which is not easy. It's easy for sums and averages and calculating word counts, but estimating a regression model on a parallel MapReduce framework isn't trivial. But we'll show you. And then, high-speed disks. They need high-speed disks because, again, that's the bottleneck. So that's that's what the industry is basically going towards, this shared nothing design. So what this is about is just commodity or non-commodity units. It doesn't matter. It depends on the vendor. You've got these grids of computing units. You distribute your data across these units, and you crunch them locally. And basically, the downside is parallel coding is required, but it scales really nice to data. You know, you can buy cheap hardware and just keep adding nodes as your data grows. And that's basically what's going on in the industry right now. And you'll hear something called backplanes. So don't be intimidated by a backplane. Backplane is just how this whole distributed all these machines, how they connect together. So it's Ethernet is a backplane, 10 GB, 1 GB Ethernets connect all these machines together, and you've got a supercomputer basically. And that's the vendors in that space is Teradata. They've been in that space for a long time. They're doing really well there. They're just very expensive. Aster, which was a great vendor, unfortunately they got purchased by Teradata. Was a very inexpensive vendor of this type of technology. Also, Greenplum is an innovator in this area. Okay, so another little interesting thing, if you're interested in like supercomputing, you can go to top500org.com and you can see who are the fastest machines. But more importantly, this is kind of hard to see here. What I just want to show you here is that of the top 500 clusters are 82% of all the top 500 supercomputers. So you can just see that this paradigm of cluster computing is the way to go. All right, so now you've got distributed computing in your mind. So what, Zubin? Cool. Oh, what do I do with it? All right, so let's talk a little bit about HDFS, Hadoop file system. All right, I just want you to kind of learn about what Hadoop file system is. So on top of Hadoop, we'll talk about MapReduce. We're not in MapReduce yet. So what HDFS is just a distributed file system. It's just a low-level thing that handles your data. So basically, you have your data set here. It'll say, okay, we're gonna say crunch it into 5 pieces because we got 5 nodes, and it'll basically distribute those pieces to your nodes in an interesting way. So you got node 2, 4, 5. You got data element 1, data partition 1, 2, 5, etc. There. So what it's doing is it's doing all that for you. It allocates the data to your partitions, and then it says, okay, this is the primary partition, 2, 1. So you got 1, 2, 3, 4, 5. You got all your data distributed. And it says, okay, these are my primary partitions. So then what it does, it says, okay, you've got these backups. And what the beautiful thing about HDFS is that it manages all this for you. So if this server goes down, this one will say, okay, the master will say, okay, server B over here, also activate partition 2. So now I don't lose any of my, I lose a node, but I don't lose any of my data, basically. I don't lose any computing of my data. And that's all HDFS does. So you can read all about these, how crazy it is and how technology advanced it is. That's all it does. It manages that for you, that low-level data partition, so you don't have to worry about it. The cool thing is, again, is that it scales and it handles, it self-heals, right? It self-heals. So that's the big innovation with HDFS. Okay, so now what do you do with it? Let's talk about MapReduce. So MapReduce is what you've seen a lot of commercial vendors are moving towards. You just saw what IBM is moving towards. This is probably the future for us for big data in the analytics industry and how we can crunch data. This is how it works. So you've got your raw data, right? We've got these 2 partitions here, 2 nodes. And so there's a map and a reduce phase. So the mapping phase takes your data, node 1, and you create a program. And this is where you hear the term NoSQL. Okay, it doesn't mean NoSQL. It means not only SQL. Right? That's what NoSQL means. And so what these systems do, these MapReduce systems are capable, what's interesting is you don't have to use SQL. Right? You can use any language you want. You can use R, you can use C#, you can use F#, you can use Java. Whatever runs on that machine, basically, you can utilize. You can write a little script and say, okay, if I just want to create sums here, I just write a little script to say, okay, my node, sum all these group by this column here, A, B, C. And then node 2, this smaller partition, do my sum. Right? That's the mapping phase. That says I take my raw data set and I map it to an intermediate data set. And I just write some code to do that. It can be in any language. That's why, again, it's NoSQL, not only SQL. Okay, so then you need a reduce phase. So you got the distributed network. Now you need to basically stitch the result sets back together again. And that's what reduce is. So you write another module, another piece of code that has the logic on how to basically stitch these result sets together again to get your sum. And that's basically, that's HDFS, Hadoop, and MapReduce. That's basically all it is. And the reason why it's so popular, it's so simple.